Today I'm here to talk to you about small engine carburetors. We're going to primarily focus on 4-stroke cycle carburetors, and we'll cover 2-stroke cycle carburetors a little bit, but we'll get to them more in a future video segment. But speaking about carburetors, I have several different styles laid out here for you, from high performance motorcycle slide style carburetors like you'd find on this Briggs & Stratton 206 engine, to your more typical carburetors. This is off of a Honda clone engine, to even some of the unique carburetor designs, like this is a Pulsajet carburetor off of a Briggs & Stratton lawnmower engine. All these carburetor designs use the same basic systems and principles we've talked about in class. They all have a venturi area, they have some type of a float type of circuit, an idle circuit, a main metering system, and those circuits work together to allow the carburetor to provide the right amount of fuel with the amount of air that's going into the engine. Now when it comes to small engines, one of the most common problems you'll find with them is clogged up carburetor passages. Today's fuels, they have a shelf life of about 90 days, and after that the fuel begins to break down. It might be able to start up and run even if it's 6 months to maybe a year old, but beyond that the fuel will break down to the point where it will really clog up those carburetor passages and cause you a lot of headaches. Over here I have some different products to help prevent that. One thing I recommend that everybody uses is some type of fuel stabilizer in their outdoor power equipment, motorcycles, go-karts. If you're going to have something that sits around, put fuel stabilizer in it. The classic complaint is, oh, I thought I was going to mow the yard one more time that season or go for one last motorcycle ride, and then you don't, and then that fuel goes in there and it stays inside the carburetor circuits. It starts to solidify and clogs everything up and causes you all kinds of headaches. So what we're going to do is jump into a few things here and look at some of these different carburetors in more detail. Again, I'm going to focus on this side draft style carburetor. It's pretty popular today in your outdoor power equipment. It's not as specialized as something like this one off of this pit bike, and it's not as old school, if you will, as something like the Pulsajet carburetor. This style carburetor, just to give you a quick rundown, is the float system actually takes place in little wells built into the fuel tank. It's almost like the fuel tank becomes the float bowl, if you will, and it's got a diaphragm that sits in here that pulls the fuel up from the fuel tank, stores it in the top of the fuel tank where it can be then brought into the carburetor and discharged into the airstream. If you look at this carburetor, it's kind of a downdraft design in that the airflow goes down through the top of the carburetor and then it goes over into the small engine. Not the best flowing carburetor or anything like that, but very simple, very cheap to produce, and it got the job done for a lot of years. With this style, what I would recommend is either replacing the whole assembly or at least replacing the diaphragms on it and then running the whole thing through a good cleaning cycle. Again, just to give you one other type, this would be a diaphragm style carburetor like you'd find on a chainsaw or a blower. The manufacturers of these carburetors and the products that use these, manufacturers like Stihl, they actually recommend that you don't use carburetor cleaner on them, that you use brake cleaner on there to clean these carburetors up. And again, we'll get into that in a future video. Now, why brake cleaners rather than carburetor cleaners? Well, they're a little bit less caustic and they're less likely to eat up those diaphragms. But this style carburetor, these are very similar. They're two of the same, if you will. This is what I want to focus on today. And first we'll point out some of the differences between these two carburetors, then we'll take them apart and we'll get them ready to clean them up. Okay, you see I have some tools laid out here to begin to work on the carburetors. If you're cleaning the carburetors, spraying them out, I always recommend you have some safety glasses with you. you don't need a lot of tools. I have a Phillips head screwdriver, a flathead screwdriver, a 10mm for this one. I want to remove this fuel hose. I'm going to clip the little wire tie that was on there. And as far as pulling that fuel hose off, whenever you're removing fuel hoses, here I have some fuel hose pliers, which makes the job kind of nice. But the tip I want to give you is to always twist the hose back and forth as you pull. If you just try to pull, you'll really fight the hose off of there and you're likely to rip it. If you twist the hose as you pull it, it will come off of there much, much easier. Okay, so we have this carburetor here on the bench, and I have its cousin right next to it here. Let me show you what's different about these two carburetors. I've tried to position this as you're looking right over my shoulder as I work on them. So this carburetor here likely came off of a federal engine, an engine built for a different state besides California. Maybe Nevada, maybe Arizona, Mississippi, a state with less stringent emissions regulations. And why am I saying that? Right here, this is the idle mixture screw. If I compare that to this other carburetor, you notice that its idle mixture screw is completely plugged off, which is typical for carburetors in California. They don't want us to make these mixture adjustments because if we adjust the air-fuel mixture, that's going to affect the emissions that the engine produces. So this one not having a mixture screw versus this other one having a mixture screw is what kind of signals to me that we have carburetors made for two different markets here. Now if I look at the brand, they're both the same brand of carburetor. However, two different markets that they're being produced in. Let's start to look at some of the components here on these carburetors and what your adjustments would be. Okay, so with that, I have my idle mixture screw. This is my idle speed screw on the carburetor. So those are my two adjustments I can make. I can change the idle speed and I can change the idle mixture on this carburetor. This brass plug right here, that is a Welch plug, and it basically plugs off some of the idle passages in the carburetor, or they physically have to drill those passages at the assembly line, and so this allows them to basically plug or clog that off, plug it off from outside air entering the carburetor, because we want fuel to flow through those passages. Let me show you what I mean here. As we turn this carburetor around, we're looking down the throat of the carburetor, and what you'll first notice is, hey, this is closed off because this is my choke valve, and my choke was closed. So now I've opened up the choke, and I can kind of see down that carburetor a little bit better. Now, once I'm looking down the carburetor, I'll notice that there's a couple of passages here and there, and there's also a passage right here. So what do I have going on here? Well, this first one, if I follow this back, I can see it goes down through here, goes through there, and to the bottom there. That basically is a bowl vent to the float bowl of this carburetor. So that's my bowl vent there. This passage right here would be my idle air bleed. If I follow this back, I can see that there's a passage that leads right to the Welch plug and to the idle mixture screw. So that's my idle air bleed. And then that would mean that this guy over here probably ties into my main metering system air bleed in there. Remember that I want to try to mix up the air and fuel together as much as I can, and we'll use air bleeds for that. So if you have a carburetor that's running poorly, one thing that you can do to help clear it out is take your can of carburetor cleaner, or one thing you can do is take your can of carburetor cleaner, or actually, like I recommended to you earlier, is take that can of brake cleaner here. Take that can of brake cleaner and spray out these air bleeds, and that will often unclog up those passages inside the carburetor. Now, if I follow this idle air bleed passage through the side body of the carburetor, and I get to over here, I'll see where the idle discharge port is inside that carburetor. So looking for that idle discharge port, if you look on the screen here, it's pretty tough to see because the passages are that small, but there's a little tiny hole right there by the tip of my pen. That's where the air and fuel would come out from my idle circuit on this particular carburetor. To try to make it more visible, what I'm going to do is I'm going to take out the idle mixture screw and take out this idle mixture screw right here, and when I do that I'm going to count the turns. If I'm working on a carburetor and I don't want to mess up its adjustments, I want them the same as it was before, it's really important that as you do these things you count the turns. So let's count the turns to a lightly seated position. So there's 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I had 4 turns to a lightly seated position. When I put this all back together, when I'm all done and I'm reassembling, I just have to remember to put that back to 4 turns out from a lightly seated position. Don't make these screws super tight. Okay, so I've made my notation 4 turns out from a lightly seated position and try to zoom in on this thing. I'm still not positive that you'll be able to see it 100% on the video, so I did my best drawing rendition here. That's the tip of the idle mixture. So you can see it's a tapered tip that goes into a seat, and that physically pinches off the fuel flow through the idle circuit. So as we screw the screw in, turn it clockwise movement moving in would pinch off the fuel flow, thereby leaning out the mixture. If we unscrewed it, right, turning it counterclockwise, we would pull it off its seat and richen up the air-fuel mixture. So be very careful when you go to seat those, and do not make them very tight. That's why we say lightly seated. So now we've taken out that idle mixture screw. I'm going to move my note and the idle mixture screw to the side and try to get this carburetor back on the screen for you, because before I was trying to show you how tiny the idle discharge port is. Well, I'm going to put some light behind it, and now you can see that little bit of light shining through the carburetor. That tells you how small the passage is. The passages in small engine carburetors are even smaller than those that you would find in automotive carburetors, and that's why they commonly get clogged up when the fuel begins to go bad inside the engine. Okay, so now that we've taken out the idle mixture screw, let's take this carburetor apart. There's really not much to it. Now, a good thing to do at the end of the season, in addition to running fuel stabilizer, would be to take out this screw right here. This is a float bowl drain. Float bowl drain. If you took it out, you could drain the fuel out of your float bowl. I'm also going to take off the bottom float bowl nut. Ooh, that somebody has put on there way too tightly. With some needle nose pliers, I'm going to take off the float. I'm going to pull this little float pin out of there very carefully. Lay him down. Pull the float out. You can see this has a Viaton or rubber tipped needle. So there's the needle attached to the float. I can take that guy off if I'd like, but I think I'm going to just leave him on there so I don't mess up that adjustment. That would be the seat that the needle closes against to pinch off the fuel flow. I have an O-ring that goes along the float bowl area. I also have this little fuel shut-off valve inside there. But I'm going to encourage you guys to not take stuff apart that you don't need to take apart. For instance, I could take the throttle valve off the throttle here, but they are very difficult to center, and so I don't recommend that you do that, because really there's no need. If my goal is to try to get this carburetor cleaned out, the tiny passages are those for the idle and the main metering system, so I do want to pull out the main metering jet. Now, I'll do one other thing that, again, I wouldn't normally do, but for the sake of our video, to clear things up and allow you to see inside there, I'm going to take these needle nose pliers. I just pulled the choke valve right out of this carburetor. Once I've done that, I can then lift out the plastic choke pivot, and now I can see through the body of the carburetor a little bit more easily. I'll set up my light again behind here so that we can look right down the body of this carburetor. Well, we almost had too much light there, but here we're looking down the body of the carburetor, and what I'm trying to point out is that this little tip right here functions as the main nozzle inside the carburetor. That's where the fuel is discharged in the center of the main metering system, and if you can see that, it does get narrower in the center of the carburetor. So there's that main nozzle and the venturi area of the carburetor. So we're going to take that out, because that main nozzle is actually part of our emulsion tube, or commonly called by us racers the E-tube. Now I do want to show off a couple more things. I have some different flathead screwdrivers here. This is your typical 1/4-inch blade flathead screwdriver, but next to it I have a jet screwdriver. If I can get my light out of the way, what you'll see is that the sides of it are nice and straight. It doesn't have the taper or shoulders here. I'll also get out my pocket screwdriver. These are super handy to have, but again, the sides of that screwdriver are not straight. Although I could get a standard screwdriver in there, the safest thing to use would be the jet driver, because it actually fits the carburetor jet more securely, and without the shoulders there, it allows you to have maximum blade width without rubbing on the sides. So, giving a little tap here to get out the main jet. And that right there is your main metering jet. Now what about this emulsion tube, or E-tube? Well, it's a little stuck. I'm getting it. This guy was so stuck, I had to go get another tool to help me get this guy out of there. I used my 90-degree pick tool just to kind of press on this to get this out. This is the emulsion tube. Now I'll lay him down and the jet next to it and really zoom in on these so that you can see them more clearly. So these passages are so small, I had to get a different camera to really show them to you. Here's the main metering jet. The orifice on there is probably about 38 thousandths of an inch. Here's the emulsion tube. You can see the passages in it. When this item goes together, if I flip this jet around, you can see there's where my screwdriver would fit in to remove the jet. It has threads on the side of it, so again, that's my main metering jet. And how these would fit together inside the carburetor is that the emulsion tube
sits right on the end of the jet, so the fuel goes through the main metering jet up the emulsion tube where it begins to get mixed with air, and then it gets discharged right out the tip of the emulsion tube, which becomes the main nozzle, which sticks right inside the venturi area of the carburetor. So if I take this carburetor, you can see inside of it now, and I were to put that emulsion tube in there, you can now see the center venturi area of the carburetor and how the emulsion tube pokes right out there and becomes the main nozzle. Now, what about cleaning this thing? At this point, we're ready to clean the body of the carburetor and throw it in one of my favorite tools, the ultrasonic cleaner. So here we're at the parts washer. We're going to clean off the body of the carburetor. In fact, normally I would do this first and just clean off the whole outside body of the carb before I took it apart. This is a smart washer. It uses a microbial parts wash solution and does a pretty good job when it's heated. So if you're taking classes at the college, you go to use one of these parts washers, because we happen to have very similar ones at the school. Keep in mind that it's not going to clean very well unless it's hot. Once it's heated up and ready to go, well, it actually does a pretty decent job cleaning. So this would be good for getting off the contamination on the outside of the carburetor. Of course, you could use your can of brake cleaner. You could use maybe some simple green, a little scrub brush to scrub off your carburetor and clean it up. Either one of those things would work fine. And then once you have the carburetor disassembled like this one, you could blow out every passage, whether it's the main metering, whether it's your needle and seat, your float bowl vent right there, that we talked about, the idle air bleeds. So you could use that to clean off the entire carburetor, and that would work fine as well. But I mentioned a couple of my favorite parts washing tools, and those are my ultrasonic cleaners. Now, I'm lucky enough to have two of those. One is my industrial one, and the other one is something that just about everybody could afford to pick up. So let's check those out. So I have two parts washers here. This is your professional ultrasonic cleaner, and what it means is that it's going to vibrate the parts at a high frequency, and what that does is a really good job of cleaning out all the passages, especially like one of the carburetors I showed you earlier, where we couldn't take out the idle mixture screw, so it's going to be really tricky to clear out those idle passages, and ultrasonic cleaner works well for that. But this unit here is a couple $100 and would be pretty expensive for the average do-it-yourselfer to purchase. This one right here is made by Chicago Electric. It's one that you could get at Harbor Freight Tools, and although it looks pretty simple, and mine's been well used, so it's a little beat up, the actual control screen is missing, it actually does a pretty decent job cleaning parts. So we're going to go ahead and use each one, and I'll show you how those work and how well they clean up. So what you can see here is I've plugged in the small, inexpensive Harbor Freight, somewhere around $30 to maybe $45 ultrasonic cleaner. I've dropped in our carburetor. I could drop in a few parts too if I wanted to get those cleaned up and cleaned out. I'll go ahead and put in the float bowl. I've somewhat disassembled this guy. And I'm going to turn it on. Again, I've used this one so much the control panel came off. But that button right there turns them on. And you can hear him buzzing away. And that vibration is going to start cleaning that carburetor. Now, what can you put in there to clean with? Well, a soapy water solution actually works pretty well. I used a little bit of the fluid out of my parts washer, but a little bit of warm water with some liquid dish soap, like some Dawn, works really well. Again, a somewhat diluted mixture of simple green and water work well. If the water is warm, if it's heated water when you put it in there, it will clean faster. It'll speed up the cleaning time and do a little bit better job. But I would caution you, I've actually had it take plating off of some of these components if I left them in there too long, especially with hot detergent. Let's contrast this cleaner to the professional washer. So this is the professional washer. Now this unit has a heater at the bottom. The problem I have with it that I've had with every one of these ones I've owned, if it's a heated ultrasonic cleaner, it has a temperature probe in the bottom, and over time they always tend to leak around that probe. I put this guy in my parts washer, so as he leaks fluid out, it goes back into the parts washer so I don't lose any fluid. I'll turn the heater on, and I'm going to turn the timer on. And flip them on, and now you can hear that thing going to work. You see the bubbles coming out. You can also hear that this definitely is hitting that carburetor with a higher frequency. It's got a drip tray basket, and I can completely submerge the carburetor in this one, whereas the other unit I had to kind of rotate the carburetor because I couldn't completely get it covered in the solution. To try to minimize my irritation with this parts washer, I actually try to cover him in some moving blankets. That dampens the noise a little bit, or turn it on and walk away for a minute, because the sound that's produced by this style of ultrasonic cleaner can be pretty irritating. And that's one feature I like about the smaller unit, is that the noise doesn't bother me nearly as bad. These carburetors have been in the ultrasonic cleaner for quite a while now. We did kind of an experiment here. This carburetor is the one I disassembled for you in class in our video, and you can see how clean it's gotten. It's almost got some of the marking tech paint off of there. This carburetor here, I didn't even take the float bowl off. I left it totally intact. Now if I leave these in the parts washers too long, it might loosen up the Welch plug in there, so I want to be careful not to do that. Now this is a water-based cleaner, and so we would want to try to blow these out with compressed air. If you don't have compressed air handy, again, because brake fluid dries clean, you could hose this off outside in a well-ventilated area with brake cleaner and get all that water-based solution out of there. Then it would also be a smart idea to lightly coat it with maybe some WD-40 or a similar rust preventative. Then it might be smart, after cleaning it with brake cleaner, to spray it down with some WD-40 to prevent rust or a similar product. But let's look at these on the workbench again and see how clean they are on the inside, especially this one where I didn't take the float bowl off. So we just cleaned those two Honda clone carburetors out in the ultrasonic cleaner, and I wanted to show you how much dirt. The bottom of this parts washer was perfectly clean when I started cleaning those carburetors. I took out the parts basket, and you can see all the dirt and debris that came from those carburetors that now is settled at the bottom of the tank. Now, here's a tip. If you don't have compressed air, a leaf blower would work pretty decent at cleaning off the water-based detergents that you used and getting your parts dry so that they don't corrode before you put that carburetor back together. So that, on top of the brake cleaner, both would do a good job at getting all that cleaning solution off of your parts before you go back together. Okay, this might seem a little bit surprising that I didn't take the float bowl off, but we do that quite a bit in the industry. Time's money, and what I've found is oftentimes if I can take a carburetor off, throw it in the ultrasonic parts washer, and then drain it out real quick and throw it back on the engine, a lot of times just doing that will get it running again. So I've just taken off the bowl nut, taken the float bowl off of there, take off the float pan, and you can see that this thing's pretty darn clean on the inside now. So I might not have to remove the jet and everything. Now, there was one item that I didn't take out on either carburetor that I really should get into. So I'm going to zoom in here so we can really see what that is. This is my idle speed screw. I can count how many turns till he's lightly seated to figure out how to get him readjusted properly. I've already done that, and he was 3.5 turns from the lightly seated position. And I'm going to go ahead and take him out and show you one last jet on this style of carburetor. A lot of times they'll call it the idle system. They'll call it the pilot system on these small engine carburetors, whether they're for motorcycles or lawnmowers. This guy here represents your pilot jet. So another thing you could do to clean out those idle passages would be to take that pilot jet out of there and again clean out this passage in here, clean this jet out of there. Now what I can see is that it's pretty clean in here already because of the work that we've done in the ultrasonic, but if you were cleaning this out manually, pulling that pilot jet out would really help. I'll use my other camera to give you a detailed photo of the pilot jet. Okay, we're going to start some reassembly on these two carburetors. Of course, look at your inspection manual, service manual to know the correct procedures and the adjustments. Hopefully you recorded some data on how many turns out your various adjustment screws were, and now we're ready to begin assembly. Here are my two carburetors. This is my California model with the idle mixture screw plugged. This is my Federal model with the adjustable mixture screw. We're going to start. I've already put the emulsion tube and main metering jet in that carb. Here's my emulsion tube, or E-tube. We're going to set it in that carb and put in the main metering jet next. Here's the main metering jet. Drop him in. Be sure to use the proper size screwdriver. You could take a standard screwdriver and file off the sides of it to get a better fit if needed. If you don't want to actually purchase a jet screwdriver. So we've seated the jet. Next up is the float assembly. The Viaton tipped float needle is attached to the float assembly. I'm going to drop him into position. Not really an adjustment on this float because the body of the float is plastic, but if it was metal, there would be an adjustment to set the float level or the fuel level in the float bowl. So I got that float in place. I can put on the float bowl once I make sure I get the gasket dropped down into position. A quick tip on these gaskets: a little bit of 2-stroke oil or some O-ring lubricant would help the gaskets drop into place, help them seal up, give you a little bit more life out of those gaskets. Similar O-ring on the float bowl. Set up the drain in the appropriate location. $10mm. See where I'm holding the wrench? It doesn't need to be crazy tight. So I'm taking away some of my leverage there. idle mixture screw. Remember, he was 4 turns out from the seated position. Two and a half, 3, 3.5, and 4. Our pilot jet. I put a little lube on the O-ring on the jet. Now I'm going to put in my idle speed screw. For this carburetor, for demonstration purposes, I had taken out the choke valve assembly. It goes like so. It's put back together. This carburetor is now ready to go. It's ready to be put on the engine. I hope you enjoyed this video and learned something from it. Cleaning out your carburetor will solve a lot of your small engine drivability complaints. I would say on average 60 to 70% of your complaints, maybe even more, are related to restricted carburetor passages in your small engines.